Math 2414, Parametric Curves, Video 4, another example of sketching a parametric curve and eliminating a parameter. In the previous video, we put some finality on the parametric equations that gave us a parabola. We eliminated the parameter by solving one equation for t and substituting to the other, verifying the resulting equation was indeed quadratic. Hence, the graph was a parabola. But in this one, we're going to take a different approach. The parametric equations that we're going to play with, and I meant to put t instead of theta, although it really won't change anything, are x equals cosine of t and y equals sine of t. Now, if you're halfway paying attention in the first video, you already know what the graph of this looks like and you know what its equation is. But let's pretend you hadn't seen that yet. If we wanted to sketch the curve, we could do the same thing we did before, which was to take values of t and substitute them into both parametric equations, crank out some points and plot them. Now, since t is the argument of both cosine and sine, a logical thing to do would be to pick some angles that we know about. For example, all your multiples of pi over 2. On the positive, negative x-axis, positive and negative y-axis. But if you only look there, then you would get these four corners and probably draw a square. And yes, that is a square. Just because it's tilted doesn't make it not a square. I think I said that right. But anyway, so you would need to get some more points, but you should know what this graph is, because the whole thing that set this off is that it was a circle. So sometimes the best thing to do to sketch a graph is not to just jump into a table of values, but rather eliminate the parameter and then take a look at the equation that you have. So how are we going to eliminate this parameter? Well, one move would be to solve for t in one equation and substitute for the other. But if you did that, there's really no best choice here. For example, you could say that t is equal to arc sine of y, and then cram that into cosine, and say x equals cosine of arc sine of y. Quick, what's that the graph of? And don't quick, because don't answer it, because I wouldn't expect you to be able to go, I think it's a circle. And technically what you just saw wasn't, but we're not going to get super nitpicky right now. So how can we eliminate this? Well, another way to eliminate a parameter, especially when trig functions are involved, is to find a trig identity that relates those two trig functions. For example, do you know a trig identity that involves sines and cosines? You should. Cosine squared t plus sine squared t is equal to 1. So if I want to take advantage of that identity, all I have to do is replace cosine with x. This is cosine squared, so it's x squared. And replace sine of t with y. Since it's sine squared of t, we get y squared equals 1. And all of you better know that that's the equation of a unit circle. So let's add this to our list of ways to eliminate parameters. Number 2, if both parametric equations involve trig functions, comma, find a trig identity relating the two. If it's sine and cosine, then the identity is sine squared plus cosine squared is equal to 1. But let's say if it were something a little bit different. Oh, by the way, yeah, we're going to sketch this, but it's a circle. I mean, you should know that's a unit circle. So just to do it justice, there's your unit circle. But let's say we had something more along the lines of this. Let's say we have x equals tangent of t and y equals cotangent of t. And we wanted to eliminate the parameter. Well, you would have to find an identity that connects the two. What identity relates tangent and cotangent? Well, there's one primarily I have in mind that comes in a variety of forms. It's a reciprocal identity, such as cotangent of t is equal to 1 over tangent of t. In which case you would replace the cosine of t with y, the tangent of t with x, and you would get y equals 1 over x, which you probably know, and if you don't, you should, has two boomerang-looking branches like that, vertical asymptote and horizontal asymptotes both on the axes. Technically, that's called a hyperbola, but You should know that graph already. So eliminating a parameter sometimes involves trig functions and finding an identity that relates the two.